Hello dear students, I Ganesh welcome all of you to this session, and today we have to discuss on the chapter relation and function, and it is concerned to exercise 1b. In our previous class already we are discussing about some of the important questions of this chapter relation and function, and it is from exercise of our book Elements of Mathematics. Okay, so today we have to discuss with some other problems from the concerned exercise, and let us begin with those problems. Okay, so today we will start from the problem, and it is the question number 7. Okay, so it is question number 7, and the question number 7 is based on a question that I am going to write it here. It is concerned that prove that the following sets are equivalent. Prove that the following sets are equivalent. And it is given the sets as one is given as 1, 2, 3, 4, 5, 6 and so on so on. The next set is given as 2, 4, 6, 8 and so on so on. The third set is given as and so on. It should be corrected, it should be 3. Okay, and the fourth set is given as and so on so on. Okay, now my question is, today we have to show that these following sets are equivalent. So the question is, under what condition the sets are said to be equivalent? Dear students, do you know the sets are said to be equivalent under what condition? Yes, the sets are said to be equivalent if there exists a 1-1 correspondence between the elements of the set and between the elements of the set of natural numbers. You see, this is our set of natural numbers. This set it is the set of natural numbers. Okay, and let these are the other sets. Okay, suppose it is, let it is set A, let it is set B, let it is set C. Okay, now you can see there exists a 1-1 correspondence, means a 1-1 function is existing from the set N with the set A. Okay, so I am going to write the definition. Any two sets are said to be equivalent if there exists a 1-1 correspondence between the elements of the set and with set of natural numbers. Okay, so that is the definition. So you can see here we are able to, or to show that they are equivalent to each other. What we have to show? That we have to show that there exists a 1-1 correspondence between the elements of the set, means between the natural number and between the set A. Okay, here let f is the function from the set of natural number to the set A is f of x equals to 2x. Okay, so you see in that method 1 is transforming to 2. Okay, 2 is converting to 4, 3 is converting to 6, 4 is transforming to 8 and so on so on. Yes or no? So you see, with each and every natural number we are getting their images which are present on the set A. Okay, so we can say, and it is a 1-1 correspondence. If the elements are different, the values are different. Yes or no? So here f is from n to a as f of x is 2x is 1 1. Is what? 1 1. Therefore n is equivalent with the set A. Similarly we can say let G is the function from the set of natural number to set B as what? You can tell me, my dear students, think how the function should be defined and which should be 1 1. Suppose G of x is, it is our 2x minus 1. Okay, so if you go for 2x minus 1, you see 2 times of 1, 2 minus 1, that is 1. 2 times of 2, 4 minus 1, that is 3. 2 times of 3, 6 minus 1, that is 5. 2 times of 4, 8 minus 1, 7. 2 times of 5, 10 minus 1, that is 9. So G is the function from n to b as G of x is 2x minus 1. It is also a 1 1. It is also 1 1. And if you are interested, you can show them that it is 1 1. Okay. Similarly, can you identify? Yes, we can identify the equivalence between the set of natural numbers and between the set C. Similarly, let T is the function from n to C, or you can write H also. Okay, let it is H by T. Okay, H is from n to C. H of x equal to what? It is x square. Is also 1 1. Okay, so now we can see that we have a 1 1 correspondence existing, or we are able to show a 1 1 correspondence between the set of natural number and the elements of sets given. Okay, as the sets are given, we are denoting them by n, by a, by b and by c. So we can say that as they are existing a 1 1 correspondence, hence the sets are equivalent to each other, because that is the definition. When they are said to be equivalent, if there exists a 1 1 correspondence between the elements of the set and between the set of natural numbers. Okay, my dear students, hence the sets are, what I can say, equivalent to each other. Okay, because there exists a 1 1 correspondence. Clear? Yes or no? So my dear students, as n is equivalent to a is n is equivalent to b, n is equivalent with c, hence a, b, c and n are equivalent with each other. That is the solution of this question, of this problem. Okay, now go through it and try to learn about the concepts of equivalent and the condition of equivalent between the elements of sets. Okay, so with this we conclude this problem. Okay, now we'll move to our next problem. You see, the next problem is, we are moving, I am cleaning the board now. So you see, now we move to the next problem. The next problem is about the question number 8. And the question number 8 is, it is concerned to, let f is the function, let f is a function which is given and g is a function given. And how it is mentioned? It is mentioned as 1 is correspondent with a, 2b, 3c, 4d. Means here you can identify what is the domain element, what is the range element. Okay, and let g is the function which is defined from it is defined like ax, a is transforming to x, b is transforming to x, c is transforming to y, and d is transforming to x. Okay, so this is defined And now it is given, now we have to find out, determine Goff and fog if possible. Goff and fog if possible. Next, test whether fog equal to Goff, that we have to test. Okay, so we have to find out Goff and fog. Dear students, now what we mean by Goff and fog? Yes, we are know that fog and Goff, they are the composition of functions. G is operated on F, that is Goff. G operated on F, G applied on F. The elements of the range value of F are behaving like the elements for G. G of F of X, that is our Goff. And what is fog? F is operated on G. So the elements of the range set of G are behaving like the elements of the domain set F. In that case, whether Goff and fog are possible, now we are going to find out. And after it, we will check fog is equal to Goff. So it is a question based on the composition of functions. So you see, we are defining in our previous lecture also, we are discussing about the one-one function, about the injectivity, about the subjective condition, about the bijective condition, yes or no. So we are defining like this. And here also we discuss, on this video we are discussing about the equivalent of sets. Now we are some questions are there, some problems are there based on the composition. So let us go for this composition. Okay, better let us explain it, let us try to learn it through example. So what F do? If I make a picture, you see F is converting the elements 1 to A. F is the function, and 2 is converting to form of B, 3 is transforming to C, and 4 is transforming to D. Okay, and what the G do? G is applied on the elements of A, B, C, D, and it converts those elements. This is the function G. It converts A to X, B to X, and C to Y, and D to X. So this is the conversion. Okay. So at that case, we have to find Goff. So you see here, Goff is what? We have to write down. So you know Goff means, Goff X means, here G is operated on what? The elements of, the range elements of G of F of 1. Okay, and what is G of F of 1? You know F of 1 is A. Yes or no? F of 1 is A. And G applied on that element and it is converting to X. Okay, so how to find Goff X? Here Goff X, or simply Goff, that is abbreviated. So now similarly, so I can say Goff 1, and now I will go for Goff 2. What is Goff 2? G of F of 2. And what is F of 2? It is G of B, and G of B is also X. Now we are going for Goff 3. So it is G of F of 3, and you see what is F of 3? F of 3 is C. So it is G of F of 3 is C. So G of C means it is again converted to Y. Now Goff 4. Okay. So it is G of F of 4, which I can say G of D, which is again converting to X. Okay. So now we see through Goff what we observe. Therefore we can say we will go for Goff is what we denote. 1 is linked with X. Yes or no? 1 is transforming to X. And it is a composition. Two functions are mixed to form the transformation of 1 to X. Okay. Now 2 is similarly related in Goff. 2 is related to X. And 3 is related to Y. 4 is related to X. Okay. So my dear students, that is the way to define Goff. Now we are going to find fog. You see fog X. that is also there fog x. So what it means? F of g of x. Okay, that is the meaning of fog x. So you see fog x means, so we are going for the elements of g, therefore fog a. So we are going for the elements of g of a. G of a is what? X. So is f is applicable on x? No, my dear students. F can't convert the value of x to some other value. Why? Because that element does not belong to the domain of f. As so similarly for other elements, as x does not belongs to domain of f, that implies fog x does not exist. Okay? Yes or no? So your g of a is it is x. It is f of g of a. Your g of a is x. So but f of x does not exist because f is converting 1, 2, 3, 4. It is not applied on x. Okay? So as x does not belong into domain, so fog x does not exist. So here you can see that we are able to define GOF, but we are not able to find out fog. So whether fog is equal to GOF? Yes, they are not equal. Therefore, fog and GOF are not equal because fog is not existing already. Okay. So how we can equality is happen when they are equal, when they are having same domain elements or they are having same image elements, but here the functions are not equal with each other. Okay, so this is a problem related to fog and GOF, and my dear students, look carefully and check out that how we are able to find GOF and how we are finding fog, what is the rule behind of it. Again I am telling, in GOF here GOF x means what? It is g of f of x. Okay, so g is applied on the elements of f of x, means those elements, those range elements of f are behaving like a element of the function g. Okay, here you see initially 1 is there. Okay, f is applied on it, f of 1 is what? A. So that is the range value of f, and that value is behaving like a domain element of the set g, which is able to convert by g to the value of x. Okay, so in this way we are able to find out GOF. Similarly for other elements. Okay, and you see there is the range element of g is not behaving like, is not present as a variable or is not present as a domain element of the function f. So that value, that fog does not exist. So this is concerned to composition. This problem is concerned to composition of functions. Okay, my dear students. So now what I think, you are able to find composition of functions and you are able to solve this problem. Okay, now we'll proceed to another problem. Okay, for your clarity. So let us move to another problem. I am going to clean the board now. Let us go for another problem. That is, suppose question number 9. You see, what is question number 9? It is defined, let f is a function which is defined like 1, 3, 2, 4 and 3, 7. You see, f is defined like this and g is the function. And g is written in the form of 3, 2, 4371. Okay. So it is given determine fog and gulf. Again it is a question related to composition of function. Determine fog and gulf. If possible. So we have to find out fog and gulf if possible. Also given test whether fog equal to gulf. Test whether fog equal to gulf. Okay. So my dear students, this question, this problem is based on composition of functions, as we have to find out fog and gulf. Now let us move to solve it through pictorial way. Okay, let us try to learn how we are getting the composition through pictorial way, through diagram. Okay, for it I am drawing a diagram for your clarity. So what the function f do, it converts the elements 1, 2, 3 to the value of 3, 4 and 7. Okay. Now what the function g do, again it converts the elements of f to the value of 2, to the value of 3 and to the value of 1. Okay. So in this way it is again converting the elements. Okay. Now our question is best to find out fog. Okay. So here fog x. Yes, now what I hope you are clear about fog x. So how to find fog x? It is f of g of x. Yes or no, my dear students? So first of all we will go for the elements of g. Then we have to find g of x. That total range value is behaving like an element of f. So here you see in fog is applied, so means we have to apply on the elements of g. You see what is g is applied, it is initially applied on 3. So how it is evaluated? F of g of 3. Okay, yes or no? So what we do, g of 3, you see what is g of 3? 3 is converting to 2. Clear? So I can say it is f of 2. Now you see f of 2, if f is applied on 2, it converts 2 to 4. So I am getting 4. Now similarly fog 4 means what? It is f of g of 4. Okay. And f of g of 4 means it is 3 and f of 3 is 7. Now similarly it is fog 7, it is f of g of 7. And my dear students, what is g of 7? It is 1. So f of 1 is 3. Okay. So in this way we are able to convert the elements of the fog as. Therefore what is fog? Yes, we can write fog is, so through the composition of f and g, 3 is converting to 4, which is not written at here, but you can see the composition. How we can see again? Again you can see it is fog, means g is initially there, 3 is converting to 2, 2 is converting to 4. So 3 is directly converting to 4, which is written at here. So it is 3, 4 and 4 is converting to 3, 3 is converting to 7, which is written at here. So 4, 7 and 7 is converting to 1 and 1 is converting to 3. So fog 7 is 3. So it is 7, 3. Okay. So in this way fog is defined. Okay. Now we will go to find out gulf. Okay. So here again gulf x. What it means? Gulf x means it is g of f of x. Okay, my dear students. So you see gulf is applied on what elements? It applied on elements of f. So gulf 1. What it value? It is g of f of 1. Okay. And what is g of f of 1? F of 1 is 3. So it is g of 3. And what is g of 3? It is 2. So you see here gulf function, what it do? It converts the elements of 1 to the value of 2. Now GOF 2. Okay, how we'll solve it? You see, it is g of f of 2 and it is g of 4. F of 2 is 4 and g of 4 is 3. And how to find GOF 3? It is g of f of 3 and g of f of 3 is 7. So g of 7 is 1. Okay, my dear students, in this way we are able to convert the elements of through GOF, we are able to convert the elements of 1, 2, 3 to a new value 2, 3, 1. Okay, through the composition of G and F. Therefore, I can say, what is GOF? GOF is 1, 2, 2, 3, 3, 1. Okay, you see what is GOF? Again, I am showing you. GOF means 1 is converting to 3, 3 is converting to 2. So 1 is converting to 2. 2 is converting to 4, 4 is converting to 3. So 2 is indirectly converting to 3. 3 is converting to 7, 7 is converting to 1. So I can say it is 3, 1. Okay. So in this way our GOF function is defined. Okay. So this is concerned to our composition of functions. Clear? Okay. So what I hope you are learning about the concepts of the composition from here also. Now the question is whether fog is equal to GOF. You see, my dear students, whether fog and GOF are equal, they are not equal. Therefore, fog is not equal to GOF. Okay. So this is concerned about the composition of functions. Clear? Now we move to some other problems. So I am cleaning the board now. You see, so we will go for the composition, and the composition says, it is question number 10. Okay. Some other problems are there. Let f of x is equal to root x and g of x equals to 1 minus x square. That is mentioned. That is given. Okay. It is given, find natural domains of f and g. Means we have to find out the domain of f and g, both functions, one part. And next we have to compute fog and GOF and find their natural domains. That is another part is there. So it is concerned to composition. Next is find the natural domain. Find the natural domain of h of x equal to 1 minus x. Next is so that h is equal to GOF. The functions are equal. Okay, only if it is given, only it is only on R0, where R0 is indicating x belongs to R, such that x is greater than or equal to 0, and not on R. Okay, so this is concerned about the question number 10. Okay, so let us start quickly with the questions of question number 10 with the bits. The first bit says, so what is given? So you know f of x, it is given as root x, and g of x is given as 1 minus x square. Okay. Now tell me, my dear students, what should be the domain of f? Means what element I should input that I will get a valid output. Yes, you are correct. Therefore, domain of f is the values 0 to infinite. Clear? As it is valid, root under x can be found if it lies in the interval 0 to infinite. For negative value, we can't find the root value, and that's why f of x does not exist. Now similarly, domain of g, you see, as it is written in form of 1 minus x square, so domain of g is very clear, it is set of real numbers. Okay. So now we are able to find the option 1, we are able to find the domain of f and domain of g. Means what should be the value I can input. That's why we are able to find domain f and domain g. Now we have to find out fog and gauge. Okay, that is the second option. Here fog x means what? It is f of g of x. Okay, and what is fog x? You see, f of g of x means, what is g of x? It is 1 minus x square. And as I suggest you that in case of evaluating the function, the element, the range of g is behaving like the domain element of f. Yes or no? So here 1 minus x square is behaving like an element for the function f. And what the function do? It converts all its input values in the format of root x. So here 1 minus x square is also behaving like an element, so the output is root under 1 minus x square. So I can say fog x is what? It is root under 1 minus x square. Clear? Now we are going to find gauge. Okay. Similarly, you can say me, what is our gauge x? It is best as g of f of x. And what is g of f of x? And it is f of x is root x. So it is 1 minus root x square. So you can say 1 minus x. Clear? So in this way we are able to find both the compositions fog and gauge. Now we have to go for the domain value. What I should put in what I should put, that's why I am getting a valid output, that is called as domain. Okay, that's I am going to solve now. You see, for this, you see here I am going to solve. Here fog x, here as I am going to solve it, you see here fog x is what? Root under 1 minus x square. You see this 1 minus x square should be positive or equal to 0. Then only the root under is evaluated. That implies 1 is greater than or equal to x square. Therefore, x should be lies between minus 1 to plus 1. Therefore, the value of x is oscillating between minus 1 to plus 1. Therefore, domain of fog is the interval minus 1 to plus 1. Okay. Now we are going to find out the gauge x, and we are defining it here. Now you can tell me that as gauge x, similarly, as gauge x is here written as 1 minus root under x square or 1 minus x. So that should be valid if root x is positive, though it is converted in the form of 1 minus x, but it is converted through root x. Okay. That's why the value of x should be such a value that root x is positive. Okay. So I can say similarly, here it is defined for what? Here for domain of fog. Okay. This is evaluated for domain of fog. Similarly, for domain of gauge function, what should be happen? Root x should be x should be what? X should be greater than or equal to 0. Okay. So it is like this. Clear? So I can say what is it is therefore domain of golf. Domain of golf. It is what? It is 0 to infinite. Okay. So now we are able to find domain of fog. We are able to find domain of golf. So this is about domain of fog and golf. Okay. Now we will go for the bit 3 and we have to find the natural domain of h of x equal to 1 minus x. Okay. Now let us move to that part. Okay. So I am cleaning this one. This portion is over. Okay. And I am cleaning this one also as please make a note of it. I am cleaning this one. Okay. So you see, again we are going for bit 3. So here h of x is what? H of x is 1 minus x. You see, so domain of h of x is, it has no obstacles are there, so we can directly put the value and we can find h of x. So h of x equal to set of real numbers which is minus infinite to plus infinite. Okay, clear? Now you see, so that h equal to golf, so now we have golf function, we have its domain, we have the h function, we have its domain. Okay, you see, h equal to golf, two functions are said to be equal. Yes, when two functions are said to be equal, h is a function, golf is a function. So the functions are said to be equal if the image elements are same. You see here the image element is 1 minus x, there is also 1 minus x. But here you see domain of golf is in the interval 0 to infinite, and that is minus infinite to plus infinite. So they are said to be equal when it is on the positive real numbers. Okay, not on total r. Clear? Therefore h equal to golf only on x greater than or equal to 0, not on r. Clear? So when h is equal to golf, if it is for the bit 4, if they are having the same domain. Okay, so we have to minimize the domain of h of x to equalize it with golf. Clear? So this question is based on a problem which is based on what? Composition of functions with the equal functions, with the rule of equal functions. Okay, my dear students, now we will move to some other problems. Okay, for your clarity. So you see, next we will go to question number 11. On 11, what is given? The question is based on find the composition of fog and golf. Find the composition of what? Fog and golf. That means we have to compose F with G, G with F. To find out the composition fog and golf. Today we have to find out and test, and also we have to test whether fog is equal to golf, and test whether fog is equal to golf. Okay, where f and g functions, where f and g are functions on R. Are functions on R. Okay. Basing on those conditions, we have to find out both fog and golf. So you see, the first one is given as f of x as x to the power 3 plus 1 g of x as x square minus 2. So f of x is given as x to the power 3 plus 1, and so it is not like this, it is x cube plus 1. Okay, my dear students, so please make a correction. And g of x is x square minus 2. G of x is x square minus 2. Okay, so can you able to find fog? Okay, now try to find out fog. So here fog x means it is f of g of x, and it is f of x square minus 2. And what the function 2? It converts the elements as x square minus 2 whole cube plus 1. Okay. Now what is Gauss function 2? Gauss of x, it is g of f of x. Okay. And it is g of f of x means it is x cube plus 1. So it will be converted as x cube plus 1 whole square minus 2. Okay, because g is converting all its input values in the form of x square minus 2. So that element is also converted, as it is an element, as it is behaving like a variable for the function g, it is converted in the form of x cube plus 1 whole square minus 2. Clear? So this is about to find out fog and Gauss. Now you can check whether they are equal. No, they are not equal. Therefore, fog is not equal to Gauss. Okay, in this way you have to find out both the fog function and the Gauss function. Clear? Now we will move to some other options, some other questions, and we have to check out them whether fog is equal to Gauss or not. Okay, so my dear students, we will go for another option where it is given as, I am cleaning this one, and we will go to the next question. So that is also based on the same condition, and here we have to find out whether fog is equal to Gauss or not. Okay, so you see what is that question? It is, suppose I am going for the third one. Here f of x is cos x, cos of x, and g of x is sin of x square. Okay. Now we have to find out fog x. What is fog x? It is f of g of x. Clear? As you see, what is g of x? It is sin of x square. Now what the function f do? It convert the element of f as cos of, so it is converting cos of sin x square. Okay, so that is the way to find out fog. Now we are going to find out Gauss. What it means? It means g of f of x. So it is g of f of x means it is cos x, and it is what the function g do? It converts the element, so it is sin of cos x square. Okay, or you can say it is sin of cos square x. Okay, so now we are able to find out the fog and Gauss, and clearly therefore fog is not equal to Gauss. Okay, so in this way you can able to convert, or you can able to find the composition of fog, f operated on g and g operated on f. Okay, now look carefully and we will proceed to our next question. Okay, so now we will move to the next question. The next question is, So now we will move to the next question, and the next question is question number 12. And what the question number 12 says, let f be a real function. Let f be a real function so that h of x equal to f of x plus f of minus x is always an even function. It is always an even function, and g of x equal to f of x minus f of minus x is always an odd function. So that is about the question of even and odd function. Okay. Now, my dear students, you know the concept of even function. When a function is said to be even, f is said to be even if we already know it, we already learned if f of minus x equals to f of x. And when it is said to be odd, if f of minus x equals to minus on f of x. Okay. So basing on that concept, here the one function is given h of x, which is f of x plus f of minus x. Okay. And we have to show it is an even function, and g of x that is represented in this way, we have to show that is an odd function. Okay. So let us go for the solution. So you see here h of x is what? F of x plus f of minus x. Okay. Now what is about an even function? Okay. So you see, as f of x is f of x plus f of minus x, I can write, or I can put in place of x, I can put minus x. Now what happened, and let us check it. Because that's why I have to put the value of x by its negative sign, and if I get the same value, then I can say it is an even function. So to check out it, what we do, as it is x is written in this format, I am replacing x by minus of x. So all these x are converting to minus of x, and this is converted as minus of minus x. Okay, so what I get? F of minus x plus minus of minus x is f of x. So you see, again I am getting f of x plus f of minus x. Okay, which is our h of x. So I can say, therefore h is what? H is an even function. Clear? Now what is g of x is written? Again, g of x equal to f of x minus f of minus x. Now to check out the even or odd nature of g, what we do, we should replace x by minus x. So what I get? Yes or no? So that's why I am getting f of minus x minus of f of x. Clear? And if I take a minus h common, so what I obtain? F of x minus f of minus x, which is h, which can be written as minus of g of x. So you see, g of minus x equal to minus of g of x. Now you tell me, my dear students, g is odd or even? Yes, you are correct. Therefore g is an odd function. Okay. So this is about the test to show that if f is a real valued, h is which is represented f of x plus f of minus x is always, and what type of function is always an even function, and g of x is always an odd function. Okay. So this is about to show an even function and odd function. Next, we will go for some important questions related to even and odd functions, as per those are very important from your exam point of view. Okay. Now its second bit is given. It has the next is it is given that basing on this quality. Now I am cleaning and I am going to write. So you see what it is given. The second option, express each of the following function, each of the following function, each of the following function as the sum of an even function and an odd function. So that means we have to show a function through a sum of even function and odd function. The same function is present, but we have to split it in two parts, out of which one is even and another is odd. Okay. Now it is a question is given. Suppose it is given as 1 plus x square. So how to represent it? So you see 1 is given. So for it what we have to do? Let f of x as 1 plus x square. Now what is f of minus x? We have to find out it here. It is means if it is f is like this, f of minus x is should be written like this. And what do we get? Okay. We know or we know f of x can be written as f of x plus f of minus x divided on 2 plus f of x minus f of minus x by 2. And we know this is a what type of function? Even function, and that is an odd function. That we already, which can be written as h of x and which can be written as g of x. Okay. So here h of x is what? We have to sum up these two. So if you go for summation, you see plus x minus x are going to be cancelled. It is 2 plus 2x square divided on 2, which is 1 plus x square. And g of x, what is g of x? If you go for subtraction, you see 1 and 1 are going to be subtracted. X square going to be subtracted. We are getting 2x on 2, which is equal to x. Okay. Therefore, f of x can be written as h of x plus g of x, which is equal to 1 plus x square plus x. Okay. So I can say, therefore f is expressed by sum of an even function and odd function. Okay. Okay. So this is concerned to the sum of an even function and odd function. Okay. So with this we are able to show a function by the sum of an even function and odd function. Next we will go for another option, that is another question, and we will check how we are able to represent a function by sum of an even function and odd function. What you have to do, if f of x is there, if function is mentioned, you have to find its f of minus x, then you have to make the summation or you have to write f of x like this. This function which is represented as h of x, which is equal to f of x plus f of x minus x by 2, is an even function, and another part which is written as g of x, which is represented like this, f of x minus f of minus x by 2, that is an odd function. Okay, so in this way you have to convert a function by sum of even and odd function. Let us clarify it with another question. Now I am going to write another question. So you see, another is f of x equals to e to the power x. So how to write it? First, what we have to do? As f of x equals to e to the power x, we have to find out f of minus x. What is f of minus x? It is e to the power minus x. It is an exponential function, so it is e to the power minus x. Now I can say, now we can write f of x can be written as because that is the way to show a function by the sum of an even or odd function. Therefore, f of x equals to, this one is h of x plus g of x. So if I go for here, h of x is what? H of x is e to the power x plus e to the power minus x on 2 divided by 2. And what is g of x? It is e to the power x minus e to the power minus x divided by 2. Okay? Therefore, f of x, it is written as e to the power x can be written as e to the power x plus e to the power minus x divided on 2 plus e to the power x minus e to the power minus x by 2. You see, it is the same result equal to e to the power x, but what we do? We are able to split it in two different functions, out of which one is even and another is odd. Therefore, f of x is expressed by sum of even and odd function. Now, if somebody asks you that which one is even, my dear students, it is the even function and that is the odd function. Okay. So, for your clarity, again I am showing it. One is even function and another is odd function. Okay. So, in this way you can able to solve the functions which are to able to convert a function by sum of an even and odd function. Okay. So, dear students, with this we concluded here, and we will solve some other problems in our next class. Till then, thank you and goodbye to all. Goodbye.